Okay, I'm going to do a second example here. Again, we're going to be using the same kinds of stuff, except this time I've gone all the way and just decided let's just make it degree 4. So let's just do it as difficult as possible. So we're going to find the polynomial that has degree 4 with zeros at positive 2 and 1 plus 2i. So looking at our information here, we first need to start by figuring out where those zeros are going to be. So let's do that. So it'll be 1, 2, 3, 4 zeros. So we need to account for all of them. And now let's actually think about what they have to be. So first off, they give us 2 for free, so I'm going to write them in here. We're going to have positive 2, and we're going to have 1 plus 2i. And now in order to fill out the other 2, we first have to see if there's conjugates, and since we have a complex number right there as one of our zeros, we need to have 1 minus 2i as another 0. So those are taken care of. But now the fourth one kind of comes up, like what is it going to be? Now I know it's tempting to put minus 2, but in fact that's not actually going to be another one, because if it was, they would have given us that information. That's a unique 0. Here we have to assume that they gave us all the information we need to find the unique zeros of this polynomial. So in fact, the only option is what it says over here. It's a double root. So we're going to have another root at positive 2. And so that's an easy place to mess up when you're first starting off, is putting that negative 2 in there, because you get something that looks kind of nice, but unfortunately it's not actually our option. Okay, so now that we've got the zeros kind of written out, we're ready to find all the factored form parts. So here, first I'm going to start with the 2's. So positive 2 is the 0, so x minus 2 is going to be my factor, and it's going to be in there twice. And then for the other one, again, I'm going to be really careful. It's going to be x minus 1 plus 2i, and x minus 1 minus 2i. Again, I'm going to keep writing this out this other step because I know it's easy to make a mistake there. Okay, for our next line, we're going to have x minus 2 squared. Up here, I'm going to have now x minus 1 minus 2i, and x minus 1 plus 2i. So again, I'm just distributing those guys in. But the nice thing is here, in order to simplify this guy, we want to find a difference of squares. So there's a hidden difference of squares in here. So it's going to be with the x minus 1s. So hopefully the color here really helps you see that. So on my next step, I'm going to have still x minus 2 squared. I'm not going to multiply it out yet. And that's going to be times x minus 1 squared minus 2i squared. Again, I'm doing that from a difference of squares. This is like a minus b, this is a plus b. And when you do that, when you combine them together, that's going to be a squared minus b squared. So that's where that comes from. Okay, my next step is now I want to actually simplify this guy. So I'm going to still leave this as x minus 2 squared for now. Over here, x minus 1 squared is going to be x squared minus 2x plus 1. And now for the second part, I can kind of do it in 2 steps. 2i squared is going to be 4i squared. And 4i squared is negative 4. So minus a negative 4 is a plus 4. And so there is that piece. And now I can rewrite this. I'm going to leave room to multiply that out now. Over here, I'm going to have x squared minus 2x plus 5. Okay, over here, I've just got a difference of squares. So x squared minus 4x plus 4. Okay, so here we go. We're ready to actually multiply this out. So we're ready to multiply this out. Let's take a look. So the last time I did the full foiling and actually showed the ghetto sprinklers in action, this time I'm going to take for granted that you can do that on your own and try and save some space here and being careful. So what I'm going to do is I'm going to try and stack them, and I'm going to multiply one term at a time. So first x squared times x squared is going to be x to the 4th. X squared times negative 2x is going to be negative 2x cubed. And x squared times positive 5 is going to be plus 5x squared. So now on to the second one. So we'll be using minus 4x this time. So negative 4x times x squared is going to be minus 4x cubed. So notice I'm lining up the like terms. Negative 4x times negative 2x is going to be plus 8x squared. Again, that's because negative times a negative is positive. And then negative 4x times positive 5 is going to be minus 20x. Okay, so second one's done. Third one, I'll use this kind of orangey color. So plus 4 times x squared is going to be plus 4x squared. plus 4 times negative 2x is going to be minus 8x, right? Okay. And then positive 4 times positive 5 will be plus 20. And so I've done everything I can and need to be ready to simplify these guys. I've just got to now combine like terms. So x to the fourth in each column minus 6x cubed. And again, I'm going a little fast, but you should probably be real careful here. Don't want to screw up on the last step. 5 plus 8 is 13, plus 4 is plus 17x squared, minus 28x plus 20. And now, unless I make a mistake, we have our final answer. Now, I don't want to just leave it at that. I want to actually verify for you that I did this correctly. So let's actually check it on my 86. Okay, so here's my 86. Let's go ahead and turn it on and use the poly feature again. So poly order, this time it was degree, oops, move it down a little bit. This time it's degree 4, so I'm going to use order 4. I'm going to punch in my coefficients. So 1x to the fourth minus 6x cubed plus 17x squared minus 28x plus 20. Let's click solved. I hope it's right. Hope it's right. Hope it's right. Please be right. Please be right. Okay, it looks bad to start off, but let's actually look at this. So we've got 1 plus 2i and 1 minus 2i. That's good. We got our two complex conjugate roots. That's a good sign. Now these other guys, notice there's a 0 in the i's, like right here. There's a 0 in the i's, so this means it's just real numbers. We've got 2.00000 and 1.99999, so I think it's safe to assume that these are both positive 2. So in fact, we have found the correct answer. This was the right polynomial. Yes! I'm especially excited because, even though you can't tell this because I edited it out, I did kind of the same problem a few minutes ago, made the video, and I did it wrong. Like my two zeros were positive 2, and I used x plus 2 as my factor. So even I make those kinds of mistakes when I'm trying to be careful. So there you go. There's a second example of standard number 8. Hopefully that's been helpful.